Hi, in this instruction video we will briefly cover the NCL31000 intelligent LED driver and visible light communication. Visible light communication is an optical communication method that works inside the visible spectrum. You can think of it as a simple amplitude modulation where the visible light is the carrier and the information signal is modulated on top of that. Actually, work on the photophone predates work in the radio spectrum. Now, visible light communication is usually a unidirectional communication method and operates in the low data rates, in the kilobits per second, not to be confused with Li-Fi, which can achieve higher data rates, but is usually a bidirectional communication method. One of the use cases for visual light communication is indoor positioning. Trying to find your way through the airport to your gate, want to locate your favorite shop within the mall, or find the product you're looking for in the supermarket, this is where this is an ideal solution. Yellow dot is one of the protocols developed to achieve that. Each LED ballast has a unique identifier, which locates its position within the building. Through visual light communication, the information is transferred to a smartphone, which will reveal its position within the building. Very high accuracies can be achieved by this, much more than can be achieved by the traditional RF methods. To enable visual light communication, we are introducing the NCL31000, a highly integrated intelligent LED driver. With connectivity options here geared towards power over Ethernet and connectivity towards a microcontroller or RF module, and of course enabling visual light communication. The driver can power the whole system with an efficient LED driver, a 3.3 volt fixed DC-DC converter, and a second converter with adjustable voltage. Rounded off with a metrology block enabling monitoring of all the system parameters. The heart of the system is an advanced light engine, allowing true dimming to dark and color blending through dual channel capabilities. And indoor positioning is enabled through yellow dot compliance. This is what the typical application schematic would look like with the MCU interface, the first DC-DC converter fixed to 3.3 volts, the adjustable DC-DC converter, and the LED driving block. This is the internal block schematic for the NCL31000, with again indicating the two DC-DC converters, the logic block accessed by the MCU, and the advanced light engine with the LED driver and fair complexity inside, which we will delve into a little deeper. The NCL31000 offers very versatile dimming control. The first possibility is through an external dim pin. This is an analog input pin where the voltage level will determine the LED current. There is also an internal reference voltage set at 200 millivolt, which sets the zero LED current. Another possibility is through an internal DAC, which is controlled by a register value, meaning the external MCU can control the dimming level in a digital way. Lastly, there's an external PWM or enable pin, which enables to toggle between the dim level on the dim pin and zero level. This also facilitates the visual light communication. This is an example of a possible system architecture. Powered from the mains, the NCL31000 is capable of driving the whole system, with an LED current going up to 3 amps, 3.3 volt fixed voltage for the control system, and an adjustable voltage for sensors and other peripherals. The NCL31000 is capable of driving luminaires up to the 150 watt range. Or powered through power over Ethernet, this is what the system would look like, as in the demo that is going to follow here. The demo setup consists of the NCL31000 board, powered through power over Ethernet, connected to a Raspberry Pi. The Raspberry Pi makes a Wi-Fi connection to an application on the mobile phone, and of course the NCL31000 drives an LED fixture. The information will be modulated through the Raspberry Pi board onto the light beam and captured by a receiver. To demonstrate the capabilities of the NCL31000 LED driver, we have made a small setup with the LED driver board, which is powered through Power over Ethernet, connected to a Raspberry Pi and driving a double LED string. The Raspberry Pi board has a hat that we developed to make a digital to analog converter, which will drive the voltage level that controls the light intensity. The Raspberry Pi will also read back the information from the metrology block within the LED driver. Then we have an app to read back the information and control, which connects to the Raspberry Pi through a local Wi-Fi network. So we can turn the LED string on, control the intensity, and we can read back the data that comes back from the metrology block. With the application, we can control the LED string, turn it on and off, change the light intensity up and down, and read back the metrology information about the circuit, power going in and out, efficiency calculation, voltages and currents throughout the circuit, with, for example, 5 volts being delivered to the Raspberry Pi. To demonstrate visual light communication, we have added 2 elements to our setup: a small receiver and speaker system. Because of the high linearity of the LED driver input and its high bandwidth capability, we can modulate audio on top of the LED brightness. You can think of it as a simple amplitude modulation, where visible light is the carrier and the audio is the modulated information on top of it. So we'll play some music from the smartphone, which is transmitted to the Raspberry Pi. The Raspberry Pi transforms this into a voltage level, which is applied to the dim input of the LED driver. This way we modulate the brightness of the LEDs. It's transmitted to the receiver, which consists of a small photodiode and a preamplifier circuit, which is then plugged into the speaker system. So if we turn on the LEDs and play some music, then we turn on the sensitivity of our receiver, and we have music transmitted through the LED brightness. If we take the receiver away from the light stream, the information goes away. If we bring it back, the signal comes back. And this can just as easily be a data stream as this is linear information that we're now transmitting as audio. To round off this video, a small roundup of the NCL31000's capabilities. It is a highly integrated LED driver, providing system power, LED driving, and metrology all in one IC. With a high input voltage, very efficient LED driver, 2 DC-DC converters to power the system, visual light communication capable, a very linear and high bandwidth dimming input with true dimming down to 0, active fault protection and diagnostics, a comprehensive measurement block, and spread spectrum options for reducing EMI. Thank you for your attention, and we invite you to browse through the material available on our website, or if you have more detailed questions, to contact us.